Hi friends, welcome back to my YouTube channel. In the last session, we have understood regarding what is the power of an AM wave. Okay, how to calculate the total power of an AM wave. So, which is calculated using a total, which is PLSB, lower side bands and upper side bands, and also the carrier power. If we sum all these things, we understood that we will try to we can calculate the total power in an AM wave. In this session, we are trying to understand regarding efficiency of an AM wave. Okay, what is this efficiency? So efficiency is nothing but so how efficient in order to understand so how much is efficient our system is. Okay, in order to understand that particular thing, we will calculate usually the efficiency. So what is this efficiency? First, we will try to understand, and then we will try to understand the efficiency of an AM wave. Oh, okay. So the in general meaning of efficiency is the quality of being efficient. Means uh, what is the quality of we are going to achieve at the end, okay, of any of the AM or any of the process. It is in generic way I'm trying to make you help you understand. Okay, so with respect to output, we will define with respect to input how is the quality of an output. If you want to measure, then in that case situation we will try to then efficiency will come into picture, how efficient the system is. For example, in this case, efficiency of an AM wave means how efficient our AM wave system generation is. Means we will generate the AM wave, how efficiently we are able to generate the AM wave. That is the uh, way we calculate the efficiency of a particular system. So in this scenario, we will try to understand the efficiency of an EMV. I hope the efficiency definition is very clear. Output with respect to input, and if you want to calculate output by input into 100, if you do, you will get the percentage efficiency. Okay, so total you will get the efficiency. So now we'll calculate. Now we are interested in the EM wave, so we will try to understand as to how efficient our EM system is. Okay, so as because of the as frequency spectrum is very important to understand, I have covered a separate session on this. You can refer to the previous session. So quickly I will try to explain you, because why always I will try to consider this frequency spectrum is this is very important. So for your examination point of view, or to solve any of the questions, one mark questions or MCQs. So this frequency spectrum is we will usually neglect this frequency spectrum, but yeah, this is very important. If you know a frequency spectrum, that means you know the concept. Okay, so once this frequency spectrum you are able to understand, then you can derive any of the formula in AM wave or anything. Okay, so this frequency spectrum I will quickly revise it for you. So this is x-axis is nothing but a frequency, and y-axis is nothing but the amplitude. So fc is nothing but the carrier frequency, fm is nothing but the modulating frequency or the message signal frequency. So the maximum amplitude that fc that is the carrier frequency signal can take is AC by 2. See, you can just map like this. So maximum these are upper side bands, these are lower side bands, and the same way follows to the this portion also, which I am highlighting now. Okay, so now in the last session with the help of frequency spectrum we have derived many of the formulas, okay, related to power. So in the same way, we will try to find out the efficiency. Because of this, I considered this particular diagram, because in between we will get PSB. Okay, in this in that way. So what is this PC? So all and that and all we will try to consider. See, efficiency of an amplitude modulation system is nothing but efficiency is represented by eta AM. Okay, so this is the symbolic representation of a AM wave efficiency. So how to calculate the efficiency? Yeah, it is very easy, as I already told you the generic definition of efficiency. So power at side bands divided by total power into 100. Okay, divided by PT into 100. So what is this PSB? PSB is nothing but power at side bands. PT is nothing but the total power. So into 100%. So if we substitute PSB and PT, so to calculate what is PSB, PT and everything, please refer to my previous session, because in that session we have detailedly we have derived like how PSB can be calculated, how total power PT can be calculated. Please, the only thing is to substitute in this particular equation, and you will get efficiency of an AM wave. You will get this equation. Okay, definitely we'll get this equation. So efficiency is now dependent only on the modulation index. So what is this modulation index? Modulation index is mu. This is a representation. So only in terms of mu, if you want to represent the efficiency, nothing. You will, in order to arrive at this equation, it is very simple. So this is the basic equation which you already know. If you want to calculate the efficiency, just substitute PSB and PT, which is calculated in the previous session. Okay, just substitute those formulas, you will arrive at this equation. So if you are having still any doubt as to how to derive at this equation, please comment in the YouTube comment section. I will try to cover one more detailed session on this, okay, if required. I thought of not wasting much of time, so I directly tried to explain you the final equation of efficiency of an AM wave, which is completely dependent on the modulation index mu. So that means eta AM, that is the efficiency of an AM wave, is equals to mu square by mu square plus 2 into 100%. So why this 100% efficiency is always calculated in terms of percentage basically. So usually, okay, in general way. So efficiency is nothing but so we have to multiply by 100. So in order to get the efficiency in terms of percentage. Okay. So this is the suppose now modulation index only will be given to you. So now they will ask you to calculate what is the efficiency of an AM wave. Simple, just substitute it and you'll get the answer in a seconds. For so what you already know, like mu, what is the maximum value if the modulation index mu can take from the last session. So what are the maximum value it can take? I will just repeat it for you. So mu is nothing but value which can take between 0 to 1. Okay, so in the same way, for satisfactory modulation, we have to have this modulation index, okay, in between 0 to 1, means it can be equal to or greater than 0 and less than or equal to 1. Okay, so in this way the value of mu can range between 0 to 1, and both are included. 0 is also included and 1 is also included. So current relations in AMWave, how to calculate the current relations. So just we will try to enter a little bit more inside. So current is also calculated in AMWave. Sometimes questions will be asked with respect to current calculation in AMWave generation. So current calculations in AM wave can be done very easily. So PT equals to 1 plus mu square by 2 into PC. This is already derived in the previous session. Please refer to the previous session. So if you know power, then if you know power, then directly we can calculate the power in terms of voltage and current. We can definitely try to derive. Okay, so IC into under root of 1 plus mu square by 2. So this is important thing. So if you know voltage and if you know current, sorry, and if you know power, then definitely you can derive current. Voltage means what? AC is nothing but amplitude. Amplitude is nothing but measurable in terms of voltage itself. So considering P equals to VI, you already know the basic relation. Just consider this particular equation. So P equals to VI means in P is known, V is already known, because V means AC or A AM. Okay, means A means the amplitude, amplitude in terms of volt only. So V means the value AC or AM, whatever is there. So then only unknown is I. You can easily calculate the unknown thing and you can get this equation in terms of current relations in AM wave. So this is all about efficiency of an AM wave. So if you have anything to understand, so please comment in the YouTube section, comment section, as I told you. And if you are not yet subscribed, please subscribe to my YouTube channel and press the bell icon to get the latest notifications. And if you want to understand any of the topics related to physics and electronics and communication, electrical and electronics, please comment in the YouTube comment section any of the topic. So I will try to cover that particular topic, and maybe that will be easy for you to understand. So thank you. Have a nice day. Bye.